Welcome to the Bedtime Lab, where we explore the wonders of the universe together, gently guiding you into a world of dreams. Tonight, let's embark on a soothing journey through the cosmos as we uncover the mystifying phenomena of supernovae and stellar explosions. Just like old friends sharing marvels of the night sky, I'll share some enchanting sleepy facts to accompany you into your slumber. And if you're feeling up for it, why not tell us where you're tuning in from? It's always a joy to know how far our bedtime stories travel. Let me share something truly intriguing. Did you know that supernovae are among the brightest events in the universe? Imagine a single star outshining an entire galaxy. It's almost as if a cosmic spotlight suddenly turns on, illuminating the vastness of space with its brilliant glow. And here's another captivating detail. These explosions are so powerful that they can briefly outshine entire galaxies, releasing more energy in a few weeks than our sun will in its entire lifetime. Isn't that astonishing? Speaking of energy, did you know that a supernova can release energy equivalent to the explosion of 10 octillion nuclear bombs? That's a 10 followed by 27 zeros. It's hard to comprehend such immense power, but it's a reminder of the unfathomable forces at play in our universe. And as these stellar giants explode, they scatter elements across space, elements that eventually become part of new stars, planets, and even life itself. In a way, we owe our very existence to these cosmic fireworks. This reminds me of another fascinating fact. The elements forged in these fiery explosions include the very same ones that make up our bodies. Can you imagine? The iron in your blood, the calcium in your bones, and the oxygen you breathe were all created in the heart of a star. It's like carrying a piece of the cosmos within us. How beautifully interconnected everything is. And here's something else to ponder. Not all stars end their lives as supernovae. Only certain types of massive stars are destined for this spectacular demise. Generally, stars need to be at least 8 times more massive than our sun to become supernovae. These are the cosmic heavyweights, living fast and dying in dramatic fashion, a far cry from the slow-burning stars like our own sun, which will end its days in a more gentle manner. While we're on the subject of stellar endings, some supernovae can leave behind fascinating remnants, such as neutron stars and black holes. Neutron stars are incredibly dense, so much so that a sugar cube-sized piece would weigh about as much as all of humanity combined. Isn't that a mind-boggling concept? And black holes, those mysterious voids from which nothing, not even light, can escape, are born from the remnants of the most massive supernovae. These enigmatic phenomena continue to intrigue scientists and dreamers alike. Speaking of dreams, have you ever wondered how astronomers detect these distant explosions? Supernovae can occur millions of light years away, yet astronomers can spot them thanks to their immense brightness and the distinct light signatures they emit. These light signatures tell us a lot about the explosion's origins and the elements involved. It's almost like reading a cosmic fingerprint. Did you know that the word supernova comes from Latin meaning new star? In ancient times, when a supernova became visible in the night sky, it appeared as a new bright star suddenly appearing where none had been before. It must have been quite a spectacle for our ancestors, sparking awe and wonder, much like the mysteries of the night sky do for us today. And here's another delightful tidbit. Supernovae are categorized into different types based on their characteristics. Type 1 supernovae typically occur in binary star systems, while Type 2 supernovae result from the collapse of a massive single star. Each type tells a unique story of cosmic evolution, a narrative written in the language of light and matter. Interestingly, supernovae don't just happen at random. The universe, in its infinite patience, has a timeline for these events. Some occur in a predictable cycle linked to the life cycles of certain stars. For example, the Crab Nebula, a remnant of a supernova observed by Chinese astronomers in the year 1054, continues to be a source of study and fascination today. As you drift into a peaceful sleep, let the thought of these magnificent cosmic events fill you with wonder. Supernovae remind us of the incredible forces shaping our universe, the cycles of birth and rebirth, and the interconnectedness of all things. So, as you lay your head to rest, dream of stars and their fiery dances, knowing that somewhere in the vast expanse of space, a star is living out its final act, leaving behind a legacy of light and life. Sweet dreams, dear friend. Let me share something that might surprise you. Supernovae not only illuminate the night sky, but also play a crucial role in the universe's chemistry. When these massive stars explode, they scatter elements like carbon, nitrogen, and oxygen into space. These elements are essential for life as we know it. In fact, without supernovae, the universe would lack the rich diversity of elements that make up planets and living organisms. Isn't it fascinating how the death of a star can lead to the birth of new worlds? Speaking of elements, did you know that supernovae are responsible for creating some of the universe's heaviest elements? Gold, for instance, is formed in the intense heat and pressure of a supernova. So, when you wear a piece of gold jewelry, you're actually wearing a fragment of a star that exploded billions of years ago. Can you imagine the journey that piece of gold has taken to become part of your everyday life? Here's something else that might tickle your curiosity. Not all supernovae are created equal. Some are more like cosmic whispers than explosions. There's a type called a failed supernova, where the star doesn't explode in a grand display. Instead, it quietly collapses into a black hole, almost as if it vanished without a trace. These failed supernovae are a reminder of how diverse and unpredictable the universe can be. Now, let's talk about time. Supernovae might seem like brief events, but their light can linger for months, even years. Imagine a cosmic fireworks show that takes its time, painting the night sky with colors long after the initial burst. It's like the universe's way of ensuring we don't miss the spectacle, allowing us to bask in its glow for an extended period. And here's a thought. Some supernovae are so rare that they occur just once every few centuries in a galaxy the size of the Milky Way. Think of them as cosmic rarities, precious and fleeting. This rarity makes each observed supernova an invaluable opportunity for astronomers to study and understand these powerful events. It's like finding a gem hidden among the stars. Have you ever wondered how scientists predict supernovae? While it might seem impossible, astronomers have developed ways to anticipate these celestial events. By observing stars that are on the brink of explosion, they can sometimes detect subtle changes in brightness and composition, offering clues that a supernova is imminent. It's as if they're reading the stars' diaries, uncovering secrets written in starlight. Here's another fascinating detail. Supernovae are not just stellar phenomena. They have a profound impact on their surrounding galaxies. When a supernova occurs, it can trigger the formation of new stars by compressing nearby gas clouds. It's a cycle of destruction and creation, where the end of one star becomes the beginning of another. This cosmic renewal is a testament to the interconnectedness of all things in the universe. Speaking of connections, did you know that supernovae can affect us here on Earth? Cosmic rays, high-energy particles from supernova explosions, travel across the universe and reach our planet. While most are deflected by Earth's magnetic field, a few penetrate our atmosphere, contributing to natural background radiation. It's a gentle reminder of our connection to the cosmos, as even the most distant stars leave their mark on our world. Here's something that might surprise you. Supernovae can help measure the expansion of the universe. Type 10 supernovae in particular are used as standard candles by astronomers. Because they have a consistent brightness, scientists can calculate their distance from us by observing how dim they appear. This method has been instrumental in understanding the universe's rate of expansion, offering insights into the mysteries of dark energy. And let me share a curious fact about naming conventions. Supernova are often named based on the year of discovery, followed by a letter or combination of letters. For instance, a supernova discovered in the year 1999 might be called 1999A. It's a simple yet effective way to catalogue these extraordinary events, ensuring that each one is recognized and remembered. Now, consider this. Supernovae are not exclusive to large galaxies. They can occur in dwarf galaxies too, tiny celestial systems with just a fraction of the stars found in galaxies like our own. The occurrence of a supernova in such a small galaxy can be quite dramatic, illuminating the entire system with its brilliance. It's like a small town hosting a grand fireworks display, lighting up the night for all to see. And here's a delightful thought. Some supernovae are visible with the naked eye. Throughout history, these rare events have been recorded by observers from various cultures, leaving behind fascinating historical accounts. In fact, the supernova that created the Crab Nebula was visible during the daytime for several weeks in the year 1054. Imagine the awe and wonder it must have inspired in those who witnessed it. Finally, let me leave you with this intriguing tidbit. Some supernovae are so powerful that they can briefly alter the night sky's appearance. When a particularly bright supernova appears, it can compete with the moon in terms of brightness, casting shadows on the ground. It's a rare cosmic phenomenon, one that transforms our perspective of the night sky, if only for a fleeting moment. As you ponder these astonishing facts, let them guide you into a world of dreams, where stars dance and galaxies sing, weaving stories of creation and transformation. May the gentle glow of distant supernovae light your path to slumber, filling your dreams with cosmic wonders and celestial mysteries. Here's a thought that might intrigue you. Supernovae aren't just isolated explosions in the vastness of space. Sometimes they occur in pairs. In what is known as a double supernova, two stars in a binary system can explode in relatively quick succession. It's akin to a cosmic duet, where both stars share their final bow in a blaze of glory. This rare event provides astronomers with a unique opportunity to study the dynamics of these celestial companions. Speaking of companions, imagine a supernova that, instead of blazing brightly, dims the light of nearby stars. This strange phenomenon happens when a supernova triggers a cascade of events that leads to the formation of a dense dust cloud. These clouds can obscure the light from other stars, creating pockets of darkness in their wake. It's a little like drawing the curtains on a galactic stage, concealing the drama unfolding behind them. Now, let's dive into the life of a star before it bursts into a supernova. Did you know that massive stars spend their last days in a state of intense fusion? This process creates heavier elements in the star's core, right up to iron. But when fusion stops, the star collapses under its own gravity, leading to a supernova. It's a dramatic end to a long life, much like the grand finale of a fireworks display. Here's something remarkable. Supernovae can produce elements like gold and platinum. These precious metals are forged in the extreme heat and pressure of a supernova explosion. So, the jewelry you wear might have originated from a star's fiery demise. Isn't it fascinating to think that such beauty can arise from such violence? Consider this intriguing detail. The remnants of a supernova, known as a supernova remnant, can persist for thousands of years. These remnants continue to glow, emitting X-rays and radio waves as they expand and interact with the surrounding interstellar medium. It's like a cosmic echo, preserving the memory of the explosion long after the initial event has faded. Speaking of persistence, did you know that some supernova remnants are visible to telescopes here on Earth? The Crab Nebula, for example, is a stunning remnant of a supernova observed in the year 1504. It's a vibrant tapestry of swirling gases and energetic particles, a testament to the enduring power of stellar explosions. Here's a curious fact. The shockwave from a supernova can travel at speeds of up to 30,000 kilometers per second. That's an astonishing speed, capable of sweeping up vast amounts of interstellar material in its path. This shockwave can compress and heat the gas it encounters, potentially triggering the birth of new stars. It's a cycle of destruction giving rise to creation, a cosmic dance that perpetuates life in the universe. Speaking of creation, some supernovae are responsible for the formation of neutron stars. These incredibly dense objects are what's left behind after a star's outer layers are blasted into space. A neutron star is so dense that a sugar cube-sized piece of it would weigh as much as all of humanity combined. It's a staggering thought, isn't it? From the ashes of a colossal explosion, something equally extraordinary emerges. Let me share another fascinating tidbit. Not all supernovae end with a whimper. Hypernovae, which are even more powerful than typical supernovae, release enormous amounts of energy. They are believed to be the sources of gamma-ray bursts, the most energetic phenomena in the universe. These bursts can release as much energy in a few seconds as our sun will over its entire lifetime. Just trying to comprehend such power can leave one in awe of the universe's capabilities. Have you ever heard about the role of supernovae in the cosmic greenhouse? When a supernova occurs, it can inject heavy elements into the surrounding interstellar medium. This process enriches the cosmic dust and gas clouds that eventually form new planets and stars. It's like nature's way of fertilizing the cosmic garden, ensuring the next generation of celestial bodies is rich in the building blocks of life. Here's a little-known fact. The light from some supernova can be gravitationally lensed by massive objects like galaxies or black holes. This bending of light can create multiple images of the same supernova appearing in different parts of the sky. It's a celestial optical illusion, revealing the intricate dance of light and gravity across the cosmos. Finally, consider this. Some of the elements created in supernovae are crucial for life as we know it. For instance, the iron in your blood was once forged in the heart of a star. It's amazing to think that our bodies contain pieces of ancient stars, linking us to the universe in a profound and intimate way. As you drift into sleep, let these stories of cosmic wonder remind you of the universe's vast and timeless beauty. Each piece of stardust, each whisper of supernova light, is a part of our shared celestial heritage, inviting you to dream of infinite possibilities. Let me take you on another journey through the fascinating world of supernovae and stellar explosions. Have you ever wondered how astronomers can detect supernovae that occurred millions of light years away? It's incredible. They look for sudden brightening in the sky, as a supernova can outshine an entire galaxy for a few days or weeks. This sudden brightness is a cosmic beacon, signaling an incredible event across the vastness of space. Now, consider this. Supernovae don't just illuminate the universe, they also sing. That's right, they emit gravitational waves, ripples in the fabric of space-time itself. These waves carry information about the explosion's dynamics and are detected by observatories like LIGO, offering a new way to listen to the cosmos and uncover the secrets hidden within these stellar cataclysms. Here's something you might find intriguing. Supernovae not only produce heavy elements, but also distribute them across the galaxy. This scattering of elements is essential for creating planets, and ultimately, without supernovae, the universe would be a much simpler place, lacking the complex chemistry needed for the development of life as we know it. Did you know that the energy from a supernova can create cosmic rays? These high-energy particles travel across space at nearly the speed of light, occasionally colliding with Earth's atmosphere. Some of these cosmic rays might even reach the surface, a gentle reminder of the powerful events happening light years away. Speaking of powerful events, there's a type of supernova known as a pair instability supernova. These occur in extremely massive stars and involve the production of matter-antimatter pairs, leading to a complete disruption of the star. Unlike other supernovae, no remnant is left behind, making it a truly spectacular end to a star's life. Imagine this. Some supernovae are so powerful they can briefly outshine the combined light of all the stars in their host galaxy. This intense brightness can last for several weeks, a truly awe-inspiring spectacle visible even to the naked eye under the right conditions. It's as if the universe puts on a brilliant light show to mark the end of a star's journey. Here's a surprising detail. Supernovae can have different colors depending on their temperature and the elements they eject. A supernova may glow in shades of blue, yellow, or red, each hue telling astronomers something about the explosion's conditions and the composition of the star. It's a colorful display that adds yet another layer to the complexity of these astronomical events. Have you ever heard about the role of supernovae in star formation? When a supernova shockwave compresses nearby gas and dust, it can trigger the birth of new stars. These newborn stars are often enriched with the elements produced by the supernova, continuing the cycle of life and death in the cosmos. It's a beautiful example of how destruction can lead to creation. Speaking of cycles, did you know supernovae can influence the rotation of galaxies? The immense energy released can drive winds that redistribute gas within a galaxy, affecting its structure and evolution. This process can lead to the formation of spiral arms and other features, shaping the galaxy over millions of years. Here's something curious. While most supernovae are the result of massive stars dying, some are caused by the explosion of a white dwarf in a binary system. This occurs when the white dwarf accretes enough material from its companion star to trigger a runaway nuclear reaction. It's a delicate balance, and when it tips, the result is a spectacular explosion. Imagine the universe as a vast, interconnected web. Supernovae play a crucial role in connecting different parts of this web by moving material across space. This movement can spread elements necessary for life, like carbon and oxygen, throughout the galaxy, seeding future solar systems with the ingredients for life. Here's another fascinating tidbit. Some supernovae are so rare and energetic that they are called superluminous supernovae. These events are up to 100 times brighter than ordinary supernovae and can occur in galaxies that are billions of light years away. They challenge our understanding of how stars explode, pushing the boundaries of astrophysical theories. Did you know that supernovae can sometimes leave behind a pulsar? These rapidly spinning neutron stars emit beams of radiation from their magnetic poles, sweeping across space like a cosmic lighthouse. If one of these beams points towards Earth, we detect it as regular pulses of radio waves, offering insight into the incredibly dense remnants of stellar explosions. Consider this: the explosion of a supernova is not only a visual spectacle, but also a source of new minerals. When the ejected material collides with interstellar dust, it can lead to the formation of tiny mineral grains. These grains can travel vast distances, eventually becoming part of new star systems and, possibly, as you reflect on these facts, let them inspire you with the wonders of the universe. The story of supernovae is one of transformation and renewal, a reminder that even in destruction, the seeds of new beginnings are sown. Each star's end is but a new chapter in the cosmic narrative, inviting you to dream of the possibilities that await in the great expanse of space. Let me share something you might not expect. Not all stellar explosions are created equal. There's a particular kind called a kilonova, which occurs when two neutron stars, or a neutron star and a black hole, collide. This cataclysmic event can produce heavy elements like gold and platinum, sprinkling them across the universe. Can you imagine? The jewelry you wear may very well have originated from such a spectacular collision. Here's a remarkable insight. Supernovae can actually affect the orbits of planets. When a star explodes, the loss of mass can alter the gravitational balance in a planetary system, potentially sending planets into new orbits or even ejecting them into interstellar space. Such dynamic changes remind us of the interconnectedness of celestial bodies. Speaking of interactions, did you know some supernovae are triggered by the gradual theft of gas from a neighboring star? This scenario occurs in binary systems, where a white dwarf begins to siphon material from its companion. When enough gas accumulates, it ignites an explosive reaction, resulting in what astronomers call a Type 1a supernova. It's a dramatic tale of cosmic thievery leading to one of the universe's most brilliant phenomena. Imagine this: supernovae can sometimes leave behind a cosmic afterglow in the form of a nebula. These beautiful, colorful clouds of gas and dust are illuminated by the energy of the explosion, creating breathtaking images that capture the imagination. Often, these nebulae become the birthplaces of new stars, continuing the cycle of life and death in the cosmos. Here's a mind-boggling fact: supernovae might have played a role in Earth's own history. There's evidence suggesting that nearby supernovae could have affected our planet's atmosphere, potentially influencing climate and even contributing to mass extinctions. It's fascinating to think that events millions of light years away might have had an impact on Earth's evolutionary path. Speaking of influence, supernovae also contribute to the cosmic dust that pervades the universe. This dust is crucial for the formation of planets and stars, and acts as the building blocks of galaxies. Without the contributions of these stellar explosions, the universe would be a much emptier place, devoid of the intricate structures we see today. Have you ever wondered about the different ways astronomers detect supernovae? Besides visible light, these explosions also emit X-rays and gamma rays. Instruments sensitive to these high-energy photons can observe supernovae in galaxies too distant for optical telescopes, offering a broader glimpse into these powerful events. And here's something surprising: not all supernova remnants are visible to the human eye. Some remain hidden in the electromagnetic spectrum, detectable only with specialized instruments like radio telescopes. These invisible remnants tell us more about the nature of the explosion and the composition of the ejected material, unveiling secrets that would otherwise go unnoticed. Consider this: the study of supernovae has provided key evidence for the accelerating expansion of the universe. Observations of distant supernovae revealed that galaxies are moving away from us at an increasing rate, a discovery that led to the proposal of dark energy, a mysterious force driving this acceleration. It's amazing how the life cycle of stars can help us understand the very fabric of the universe. Speaking of groundbreaking discoveries, did you know that some supernovae have been used as standard candles to measure cosmic distances? Type Ia supernovae, in particular, have a consistent peak brightness, allowing astronomers to calculate their distance from Earth with remarkable precision. This method has been instrumental in mapping the scale of the universe. Here's a curious thought. There are hypothetical stars known as quark stars, which could form from the remnants of a supernova. These stars are composed of quarks, the fundamental building blocks of matter, in a state even denser than neutron stars. While quark stars remain unproven, their existence would add yet another fascinating layer to the story of stellar evolution. And did you know, in rare instances, a supernova might even form a magnetar? This type of neutron star has an incredibly powerful magnetic field, trillions of times stronger than Earth's. These magnetic fields can produce bursts of radiation that shine across the cosmos, sometimes even affecting satellites orbiting our planet. Here's a unique perspective. The study of supernovae has deep roots in history. Ancient astronomers recorded supernovae as guest stars, which appeared suddenly and disappeared after a few weeks or months. These early observations laid the foundation for our modern understanding of these explosive events and the life cycles of stars. As you ponder these facts, allow yourself to be enveloped in the wonder of the universe. Supernovae and stellar explosions remind us of the ever-evolving tapestry of space, where stars are born, live and die in a cosmic dance that has been playing out long before Earth formed. Each explosion is a moment of transformation, a celestial beacon lighting the way for the next chapter in the universe's endless story, inviting you to dream beyond the stars. Here's something you might find surprising. Supernovae can emit neutrinos, those elusive subatomic particles with almost no mass that can pass through entire planets without being stopped. When a star goes supernova, it releases an enormous burst of neutrinos, which are among the first signals to reach Earth, even before the light of the explosion. These neutrinos travel at nearly the speed of light, offering a sneak preview of the impending spectacle in the sky. Isn't it fascinating how these tiny particles can tell us so much about a celestial event happening light years away? Speaking of speed, did you know that the material ejected from a supernova can travel at velocities up to 10% of the speed of light? This incredible speed means that supernova remnants expand rapidly, sweeping away surrounding gas and dust, and sometimes triggering the formation of new stars in their wake, like a cosmic domino effect. Here's an interesting tidbit. Supernovae not only create elements, but also help distribute them across the universe. In the early moments of a supernova explosion, temperatures soar to billions of degrees, allowing nuclear reactions to occur that produce elements heavier than iron. These elements are then scattered into space, seeding future generations of stars and planets with the building blocks of life. On the topic of life, let's consider the potential effects of nearby supernovae on planetary systems. While most supernovae are too distant to directly impact Earth, A nearby explosion could potentially strip a planet of its atmosphere or even alter its orbit. This leads to the intriguing possibility that supernovae might have influenced the habitability of planets in other solar systems, shaping the development of life in ways we are just beginning to understand. Now imagine this. Some supernovae occur in places where we least expect them. There's a type called a runaway supernova, which happens when a massive star is ejected from its home galaxy and explodes in the intergalactic medium. These orphaned supernovae are isolated, far from the dense environments where stars usually form, yet they add their own unique stories to the cosmic narrative. Here's a curious concept: light echoes. When a supernova explodes, its light can reflect off surrounding clouds of dust and gas, creating a phenomenon known as a light echo. These echoes can be observed long after the original explosion, providing a way to study past supernova even if we missed seeing them when they first occurred. It's like the universe's way of replaying a cosmic event for us to witness. Did you know that supernovae have different flavors, so to speak? Beyond the well-known Type 1 and core collapse supernovae, there's a rare class called pair instability supernovae. These occur in massive stars, when intense gamma rays create particle-antiparticle pairs that destabilize the star, leading to a catastrophic explosion. These supernovae are so powerful that they can completely obliterate the star, leaving no remnant behind. Speaking of remnants, some supernovae can lead to the formation of black holes. When a particularly massive star collapses under its own gravity, the resulting core is so dense that not even light can escape its gravitational pull, forming a black hole. These remnants of stellar death continue to influence their surroundings, pulling in matter and emitting powerful jets of energy detectable across the galaxy. Here's another intriguing fact. Supernovae have been recorded throughout history in various cultures, often seen as omens or significant celestial events. The supernova observed in 1054, for instance, was noted by Chinese astronomers and other civilizations as a guest star, shining brightly in the sky for nearly 2 years. Its remnants, known today as the Crab Nebula, still captivate astronomers and stargazers alike. And have you ever considered the role supernovae play in the end of a galaxy's life? As galaxies age, the rate of star formation declines, and supernovae become key players in recycling the galaxy's material, reigniting star formation in some regions while contributing to the galaxy's eventual quiet end in others. It's a reminder of the cyclical nature of the cosmos, where endings beget new beginnings. Here's a remarkable thought. Some theories suggest that supernovae might even be responsible for periodic mass extinctions on Earth. By showering the planet with cosmic rays, these explosions could have impacted Earth's climate and atmosphere, contributing to significant changes in biodiversity over geological timescales. It's a testament to the powerful influence of distant stars on our planet's history. Imagine the delicate dance of timing and chance involved in witnessing a supernova. Given their brief visibility and the vastness of space, observing one is a rare opportunity. Yet, it's a reminder of the universe's dynamism, a grand spectacle that plays out in a cosmos filled with more stars than grains of sand on all Earth's beaches. Let me share one last thought. The study of supernovae continues to evolve with technology. Instruments like gravitational wave detectors and space telescopes equipped with advanced sensors are uncovering new layers of information about these explosive events. Each discovery deepens our understanding of how stars live and die, painting a fuller picture of the ever-changing universe. As you drift off, consider how each supernova, with its brilliant demise, contributes to the grand tapestry of the cosmos. These stellar explosions are not just endings but are also beginnings, forging elements, shaping galaxies, and influencing the very fabric of space and time. Rest, knowing that the universe is a place of constant wonder and discovery. Let me share something quite mesmerizing. Did you know that some supernovae can produce elements like gold and platinum? These incredible explosions forge precious metals in their fiery cores. Can you imagine that the jewelry you wear might have originated in such a cosmic event? It's a fascinating thought that the universe sprinkles these valuable elements across vast distances, eventually finding their way to Earth and into the hands of humans. Speaking of precious processes, there's a peculiar type of supernova known as a failed supernova. When a massive star tries to go supernova, but collapses directly into a black hole instead, it leaves behind little to no visible explosion. It's like a cosmic magician's trick, where the star simply disappears into the void, leaving astronomers to ponder its mysterious vanishing act. Here's an engaging tidbit. Supernovae can illuminate hidden structures in the universe. When a supernova explodes, its intense light can reveal previously unseen clouds of gas and dust, allowing astronomers to map out the intricate web of matter that stretches across cosmic distances. It's as if these explosions hold a flashlight to the universe, casting light on the shadows and unveiling its hidden architecture. And here's another intriguing phenomenon. Certain supernovae can create cosmic rays, high-energy particles that travel across the galaxy at nearly the speed of light. These particles are energetic enough to penetrate Earth's atmosphere and cause showers of secondary particles, reaching all the way to the ground. It's a cosmic connection that links the distant heavens with our very own planet. Have you ever wondered how astronomers predict supernovae? While they can't pinpoint exact times, some stars give off telltale signs before exploding. For instance, particular stars might exhibit unusual brightness or variations in light. These subtle clues are like whispers from the stars, hinting at their impending transformation. Observing these precursor signs allows scientists to prepare telescopes and instruments to catch the stellar spectacle in action. Here's a surprising fact. Supernovae can create shock waves that heat surrounding gas to millions of degrees, causing it to emit X-rays. These high-energy emissions help astronomers study the remnants of the explosions and understand the physics behind them. It's like using the universe's own X-ray machine to peer into the remnants of cosmic cataclysms. On the topic of remnants, consider this. Some supernova remnants, known as pulsars, are highly magnetized, rotating neutron stars that emit beams of electromagnetic radiation. These remnants spin incredibly fast, some completing several rotations per second, and their regular pulsations have been described as cosmic lighthouses, guiding astronomers through the darkness of space. Here's a curious concept. Sometimes two neutron stars can merge, resulting in a kilonova, a type of explosion that is less powerful than a supernova but still incredibly luminous. These events produce gravitational waves and are thought to be responsible for creating heavy elements like gold. It's a cosmic dance of immense forces, leading to the birth of new matter in the universe. Imagine, too, the impact of supernovae on interstellar travel. The powerful radiation and energetic particles from a nearby supernova could pose significant challenges for future space explorers, necessitating advanced protection measures for long journeys. It's a reminder of how these stellar events can influence not only the cosmos, but also our aspirations to venture beyond Earth. Here's a thought-provoking notion. Some studies suggest that supernovae might have played a role in kick-starting life on Earth by triggering changes in the atmosphere and influencing the climate. These explosions might have set the stage for evolutionary leaps, nudging the development of life in new directions. It's an incredible idea that the remnants of stars could have had a hand in the emergence of life. Now, picture this. The gravitational effects of a supernova can sometimes slingshot nearby stars, sending them hurtling through space at incredible speeds. These so-called hypervelocity stars are like runaway travelers, tracing paths far from their original homes, offering astronomers clues about the dynamics of stellar interactions. Considering the cosmic scale of supernova, it's awe-inspiring to realize that they also exist on a more intimate level. In smaller galaxies, even a single supernova can have a significant impact, dispersing energy and materials that influence the entire galaxy's evolution. It underscores the profound effect these events have, no matter the size of their celestial stage. And here's something quite captivating to ponder. Supernovae can even affect time measurement. The changes in brightness and energy emissions from distant supernovae are used as standard candles to measure vast cosmic distances, helping scientists to refine their understanding of the universe's expansion. It's a testament to how these brilliant explosions illuminate both space and time. As you let these facts drift through your mind, consider the delicate interplay between stars, galaxies, and the universe itself. Each supernova, with its explosive energy and transformative power, serves as a reminder of the vibrant and ever-changing cosmos. These stellar events, while rare and brief, leave lasting imprints on the universe, shaping the very fabric of existence. Let me share yet another intriguing facet of supernovae with you. These cosmic events can serve as natural laboratories for studying the fundamental laws of physics. By observing the extreme conditions during a supernova explosion, scientists can test theories about nuclear reactions and matter under immense pressure, akin to probing the very building blocks of the universe. It's fascinating to think that these distant stellar eruptions help us refine our understanding of physics on Earth. Did you know that not all supernovae are the result of a single star's life cycle? Sometimes, white dwarfs in binary systems accumulate material from their companion stars, reaching a critical mass that triggers a catastrophic explosion. This type of supernova, known as a Type 1a, is particularly valuable for astronomers. The consistent brightness of these explosions allows them to serve as cosmic mile markers, helping to measure the universe's expansion and providing insights into dark energy. Here's a curious tidbit. The brilliant display of a supernova can actually outshine an entire galaxy for a brief period. Imagine a single star becoming so luminous that it eclipses the collective light of billions of other stars. This temporary brilliance stands as a testament to the immense power unleashed during these cosmic spectacles, offering astronomers an unparalleled opportunity to observe the aftermath and gather crucial data. Speaking of light, the color of a supernova can tell scientists a lot about its composition and the processes occurring within. The specific wavelengths of light emitted during the explosion reveal the presence of different elements, allowing scientists to analyze the star's chemical makeup. It's like a celestial fireworks show, where each hue tells a unique story about the star that once was. Have you ever wondered what happens to the energy released in a supernova? Interestingly, it can trigger the formation of new stars. The shockwave from the explosion compresses surrounding clouds of gas and dust, sparking the birth of new stellar generations. It's a beautiful cycle of destruction and creation, where the death of one star breathes life into many others, continuing the cosmic dance of the universe. Here's a surprising phenomenon. Some supernovae leave behind more unusual remnants than just neutron stars or black holes. In certain cases, the core of the exploding star forms a quark star, an exotic type of star composed of quark matter. These theoretical objects are even denser than neutron stars and push the boundaries of our understanding of matter, offering tantalizing glimpses into the universe's most extreme states. It's fascinating to consider how supernovae are not just local events, but have far-reaching implications across the cosmos. They play a crucial role in the cosmic recycling process, enriching the interstellar medium with heavy elements. This enrichment is essential for the formation of planets and, ultimately, life. Without supernovae, the universe would be a much simpler place, lacking the diversity of elements that made Earth and its inhabitants possible. Speaking of implications, did you know that supernovae can influence their host galaxies on a grand scale? The energy and material ejected during these explosions can drive powerful winds that shape the galaxy's structure, influencing star formation rates and modifying the distribution of gas and dust. It's as if these stellar titans act as cosmic architects, remodeling their host galaxies over time. And here's another fascinating aspect. Supernovae can sometimes masquerade as other phenomena. For example, the light from a supernova in a distant galaxy might be bent and magnified by the gravitational field of a massive object, like another galaxy, lying between us and the explosion. This effect, known as gravitational lensing, can create multiple images of the same supernova, providing a unique opportunity to study both the explosion and the intervening mass. Imagine for a moment the ripple effects of a supernova on neighboring solar systems. The intense radiation and shock waves could strip atmospheres from planets, potentially altering or extinguishing any life present. This cosmic interplay underscores the delicate balance of life in the universe and highlights the formidable forces at work in shaping planetary environments. Here's something intriguing to ponder. The remnants of supernovae, like pulsars, can emit beams of radiation that sweep across the sky. These beams, if aligned just right, can be detected from Earth as regular pulses of radio waves. By studying these pulsars, astronomers gain insights into the extreme environments and conditions of neutron stars, further enriching our understanding of stellar evolution. Another captivating fact is that some supernova can be triggered by the interaction of galaxies. When galaxies collide, the gravitational forces can disturb the orbits of stars, causing some to become supernova candidates. This cosmic ballet of galactic mergers can lead to bursts of star formation and the eventual explosion of massive stars, highlighting the interconnectedness of these grand celestial systems. Finally, let me share a thought-provoking notion. Supernovae have the potential to serve as cosmic beacons, signaling the presence of distant galaxies. Their luminosity and visibility across immense distances make them excellent markers for mapping the universe's structure and exploring regions far beyond our own galaxy. Consider how these powerful explosions, despite their cataclysmic nature, provide us with the means to chart the vast uncharted territories of space. As you reflect on these facts, envision the universe as a vibrant tapestry woven with the light of countless supernovae, each leaving an indelible mark on the cosmic landscape. Here's a fascinating detail about supernovae. These stellar explosions can produce cosmic rays, high-energy particles that travel across the universe at nearly the speed of light. Cosmic rays are mostly made up of protons, and when they collide with atoms in Earth's atmosphere, they create showers of secondary particles. These interactions help scientists study not only the cosmos but also the fundamental forces of physics. Imagine these tiny messengers from distant supernovae reaching our planet, offering clues about the universe's most energetic events. Speaking of cosmic messengers, did you know that neutrinos are also released during a supernova? These elusive particles have almost no mass and travel at incredible speeds, passing through most matter without interaction. Yet, during a supernova, a massive number of neutrinos are emitted, providing a rare opportunity to detect them. Neutrino observatories around the world are constantly on the lookout for these fleeting signals, as they can reveal important details about the processes occurring at a star's core during its explosive death. Here's an intriguing tidbit. Not all supernovae are equally bright or follow the same patterns. Some exhibit a peculiar light curve, brightening and fading at unpredictable rates. These oddities, known as superluminous supernovae, are among the most luminous events in the universe, outshining their more common counterparts by a large margin. The exact mechanism behind these superluminous events is still a topic of active research, with theories ranging from interaction with dense circumstellar material to the presence of highly magnetized neutron stars known as magnetars. This brings us to another captivating aspect: magnetars. These are neutron stars with incredibly strong magnetic fields, trillions of times stronger than Earth's. Sometimes, the collapse of a massive star in a supernova can lead to the formation of a magnetar. The intense magnetic field can power spectacular bursts of X-rays and gamma rays, adding another layer of wonder to the various outcomes of stellar explosions. The study of magnetars provides a glimpse into the extreme physics that govern the universe. Did you know that supernovae can also help us understand the Milky Way's history? By examining the remnants of past supernovae, astronomers can trace the chemical evolution of our galaxy. The elements forged in these explosions are the building blocks of everything we see today. In this way, supernovae act as cosmic timekeepers, offering a record of the Milky Way's dynamic past and hinting at the long journey our galaxy has undertaken. Here's something truly surprising. The study of supernova has even contributed to the understanding of time itself. Observations of distant Type Ia supernovae provided evidence for the accelerating expansion of the universe, a discovery that implied the existence of a mysterious force called dark energy. This groundbreaking insight has fundamentally changed our understanding of the cosmos and continues to challenge scientists as they probe the nature of this enigmatic force. Speaking of mysteries, have you ever considered the role of supernovae in the search for extraterrestrial life? The distribution of elements like carbon, nitrogen, and oxygen, all products of stellar explosions, is crucial for the development of life as we know it. By studying supernovae and their remnants, scientists gain a deeper understanding of how life-sustaining elements are spread throughout the galaxy, informing our search for potentially habitable worlds beyond our solar system. Here's a particularly remarkable fact. Supernovae can influence not just the physical universe, but also human culture. Throughout history, bright supernovae have been recorded by civilizations across the globe. Ancient astronomers documented these celestial events, often interpreting them as omens or divine messages. These historical records provide a rich tapestry of human engagement with the cosmos, underscoring the profound impact of stellar explosions on our cultural heritage. Speaking of cultural impact, one of the most famous supernovae in history occurred in the year 1054. The resulting supernova remnant, known today as the Crab Nebula, was visible in the daytime sky for several weeks. Chinese, Japanese, and Arab astronomers meticulously documented this event, leaving behind descriptions that continue to aid modern scientists in their study of the nebula and its central pulsar. Here's another intriguing notion. The energy from supernovae can drive the formation of molecular clouds, which are the birthplaces of new stars. This process underscores the idea that supernovae are not just destructive forces, but also catalysts for creation, playing a vital role in the ongoing cycle of stellar birth and death that shapes galaxies over billions of years. As you reflect on these surprising aspects of supernovae, imagine the intricate web of interactions that these explosions weave across the cosmos. From the smallest particles to the grand evolution of galaxies, supernovae are threads in the vast tapestry of the universe, influencing and connecting countless phenomena. Each explosion is a fleeting but powerful reminder of the dynamic and ever-changing nature of the cosmos we inhabit. Imagine the incredible forces at play when a massive star reaches the end of its life and explodes in a supernova. Did you know that the energy released in a supernova can briefly outshine an entire galaxy? For a short period, the luminosity of one of these stellar explosions can equal that of billions of stars combined. Such immense power is awe-inspiring and reminds us of the raw energy that the universe can harness. Here's a curious thought. While supernovae are often associated with the explosive end of massive stars, they can also result from the death of a smaller star caught in a binary system. When a white dwarf star in a binary system accumulates too much material from its companion, it can reach a critical mass and explode in a Type 1-over supernova. This type of supernova is particularly valuable to astronomers because of its consistent brightness, which makes it a reliable standard candle for measuring cosmic distances. Speaking of distances, have you ever wondered how supernovae can be detected from across the universe? The light from a supernova travels vast distances to reach us, and by the time it arrives, it may have traveled for millions or even billions of years. This light carries with it information about the early universe, acting as a time capsule that allows scientists to peer back into cosmic history. Here's something intriguing. Not all supernovae leave behind a visible remnant. In some cases, particularly with very massive stars, the core may collapse into a black hole without a dramatic explosion. These so-called failed supernovae are still a topic of intense study as they challenge our understanding of stellar evolution and may contribute to the population of stellar mass black holes in the universe. Imagine the echoes of a supernova rippling through space. These shockwaves can travel through interstellar material, compressing it and triggering the formation of new stars. This star-forming activity highlights the cyclical nature of the universe, where the death of one star can sow the seeds for many more, perpetuating a cosmic dance of life and death. On a more granular level, the particles released during a supernova contribute to the cosmic soup from which planets and life eventually arise. These elements, heavier than iron, are dispersed throughout the cosmos and incorporated into new star systems. It's a humbling thought that the atoms in our own bodies were forged in the fiery heart of a distant star. Have you ever considered how astronomers predict when a star is about to go supernova? By observing the light spectrum and behavior of certain stars, scientists can identify those that are likely nearing the end of their life cycle. These predictions are crucial for capturing the fleeting moment of a supernova's explosion, allowing telescopes around the world to focus on the event and gather valuable data. Here's an exciting fact. Some supernovae are so energetic that they can produce gamma-ray bursts, the most powerful explosions known in the universe. These bursts can release more energy in a few seconds than the sun will emit over its entire 10 billion year lifespan. The study of gamma-ray bursts helps scientists understand the extreme conditions and processes that occur during these rare and extraordinary events. Speaking of rarity, a supernova can dramatically alter its surrounding environment, even after the initial explosion. The intense radiation and shock waves can strip away material from nearby stars, alter the chemistry of interstellar clouds, and affect the dynamics of entire star clusters. This ongoing influence underscores the role of supernovae as agents of change within galaxies. Have you ever marveled at the beauty of a supernova remnant? These remnants, composed of expanding clouds of gas and dust, can form into stunning nebulae with intricate patterns and glowing colors. The interplay of light and shadow within these formations creates a cosmic canvas that is as captivating as it is scientifically significant. Each remnant tells a story of the cataclysmic events that shaped it and continues to intrigue astronomers and stargazers alike. Here's an interesting notion. Supernovae can influence the future habitability of planets. The radiation and energetic particles from a nearby supernova could potentially strip a planet of its atmosphere, making it inhospitable to life. However, the elements dispersed by supernovae are also essential for creating the building blocks of life. This dual role speaks to the complex and sometimes contradictory nature of cosmic phenomena and their impact on potential life beyond Earth. Have you ever thought about how the study of supernovae has led to technological advancements here on Earth? The techniques developed to observe and analyze these distant explosions have applications in a variety of fields, including medical imaging and nuclear research. The pursuit of understanding supernovae not only enriches our knowledge of the universe, but also drives innovation that can improve our lives. Finally, consider the cosmic legacy of a supernova. The elements created in these explosions are recycled into new stars, planets, and even life forms. In this way, supernovae are not just endings, but also beginnings, playing a pivotal role in the grand story of the universe. The next time you look up at the night sky, remember that you are witnessing a tapestry woven by countless supernovae over billions of years, each one contributing to the wonder and mystery of the cosmos. Did you know that supernovae can even outshine entire galaxies for a brief period? It's a remarkable reminder of their immense power. During a supernova, a single star can emit more light than billions of other stars combined, a fleeting brilliance that captivates astronomers and space enthusiasts alike. This dazzling display is a stark contrast to the star's quiet life leading up to its explosive finale. Speaking of light, supernovae are also responsible for some of the heaviest elements found in the universe. Elements such as gold, platinum, and uranium are forged in the intense heat and pressure of a supernova explosion. These precious metals and rare elements are scattered into space, eventually becoming part of planets, moons, and even our own bodies. It's awe-inspiring to think that every piece of gold jewelry or silverware has a cosmic origin story. Here's something you might find fascinating. Not all supernovae are caused by natural stellar processes. In theory, it's possible for a supernova to be triggered by human activity. If advanced civilizations were to develop technology capable of bombarding a star with vast amounts of energy, they could potentially induce a supernova. While this remains purely speculative, it opens up intriguing possibilities about the intersection of advanced technology and cosmic phenomena. Have you ever wondered about the role of neutrinos in a supernova? Neutrinos are nearly massless particles that are released in enormous quantities during a supernova event. They are incredibly elusive, passing through matter almost undetected, but their sheer numbers are instrumental in the core collapse process of massive stars. In fact, the first experimental detection of neutrinos from a supernova provided crucial evidence for our understanding of these mysterious particles. Let me share another intriguing detail. The Crab Nebula, a famous supernova remnant, is actually the result of a supernova observed by Chinese astronomers in 1054 AD. This historical account provides a rare opportunity to connect ancient observations with modern astronomical data. The Crab Nebula continues to be a subject of study, helping scientists to learn more about the life cycle of stars and the evolution of supernova remnants. And did you know that some supernovae can create cosmic rays? These high-energy particles are accelerated to nearly the speed of light by the shock waves of supernova explosions. As these cosmic rays travel through the galaxy, they can have significant effects on everything from the formation of new stars to the chemistry of planetary atmospheres. Their impact on Earth is also noteworthy, as they contribute to the background radiation we experience and may even influence cloud formation and climate. Here's an unexpected twist. Supernova can sometimes be responsible for the creation of neutron stars. When a massive star explodes, its core may collapse into an incredibly dense object known as a neutron star. These stellar remnants are so dense that a teaspoon of neutron star material would weigh billions of tons. Neutron stars, with their strong magnetic fields and rapid rotation, often manifest as pulsars, emitting beams of radiation that sweep across the sky like cosmic lighthouses. Have you considered the possibility of a supernova occurring in our own galaxy? The last known supernova in the Milky Way was recorded in 1608, and scientists expect that such events happen roughly once every 50 years in our galaxy. These occurrences are often obscured by interstellar dust, making visible sightings rare. However, modern technology allows astronomers to detect supernovae through other means, such as neutrino and gravitational wave observatories, ensuring that we won't miss the next cosmic spectacle. You might be surprised to learn that supernovae can influence the structure of entire galaxies. The energy and material they release can drive winds that shape the distribution of stars and gas within a galaxy. This feedback process can regulate star formation rates, affecting the overall evolution of galaxies over billions of years. In this way, supernovae play a crucial role in sculpting the universe on a grand scale. Consider this. Supernovae are not just destructive forces. Their remnants, rich in heavy elements, are essential for the formation of planets and the development of life. Without the contributions of supernova, the universe would lack the diversity of elements needed to create complex structures, from rocky planets to biological organisms. It's a poetic reminder of the interconnectedness of cosmic events and the ingredients that make life possible. And here's something to ponder. The study of supernovae has led to profound insights about the universe's expansion. Observations of distant Type Ia supernovae revealed that the universe is expanding at an accelerating rate, a discovery that earned the Nobel Prize in Physics in 2011. This unexpected finding pointed to the existence of a mysterious force known as dark energy, which continues to challenge our understanding of the cosmos. Finally, have you ever considered how supernovae can act as timekeepers in the universe? By examining the light curves and spectra of supernovae, astronomers can determine their age and use them to date other cosmic events. This ability to chart the passage of time on a cosmic scale provides invaluable context for understanding the history and future of the universe. Each supernova offers a unique window into the life cycles of stars and the forces that shape our universe, leaving behind a legacy that continues to illuminate the night sky and inspire wonder in all who gaze upward. Imagine the power of a supernova being so immense that for a brief moment it can outshine an entire galaxy. This staggering display of brightness is one of the most fascinating aspects of stellar explosions. In those moments, the energy released is comparable to the energy our sun would emit over its entire lifetime. Now that truly puts the power of these cosmic events into perspective, doesn't it? Let's explore the diversity among supernovae themselves. Did you know that not all supernovae are created equal? They come in different types, each with its own unique characteristics and mechanisms. For instance, Type A supernovae are particularly intriguing because they involve a binary star system. Here, a white dwarf star accretes matter from its companion until it reaches a critical mass and explodes. This type is essential for measuring cosmic distances because of their consistent brightness. Speaking of measurement, have you ever heard of the Chandrasekhar limit? It's named after the astrophysicist Subrahmanyan Chandrasekhar and represents the maximum mass a white dwarf can have before it collapses. This limit is approximately 1.4 times the mass of our Sun. Exceeding this threshold, the white dwarf undergoes a dramatic transformation, often leading to a supernova. Now, here's an intriguing fact. Some stars are so massive that when they reach the end of their lives, they don't just explode, they completely obliterate themselves, leaving nothing behind. These are called pair instability supernovae, and they occur in stars with masses between 100 and 200 times that of our Sun. Instead of forming a neutron star or black hole, the entire star is consumed in the explosion. Reflecting on cosmic cycles, did you know that supernovae play a vital role in triggering the formation of new stars? The shock waves from these explosions can compress nearby clouds of gas and dust, initiating the process of star formation. It's a beautiful cycle of destruction and creation, where the death of one star can lead to the birth of many others. In a more whimsical twist, consider this. Supernovae have even been linked to the idea of cosmic music. The vibrations and waves generated from these stellar explosions can be converted into sound waves that, while not audible to the human ear, can be translated into intriguing frequencies and melodies. It's a poetic notion that the universe might be filled with an ever-present symphony born from the life and death of stars. Another fascinating detail lies in the sheer variety of elements that these explosions produce. Heavy elements such as gold, platinum, and uranium are crafted in the intense heat and pressure of a supernova. In fact, the very air we breathe contains elements that were once part of a star. Isn't it remarkable to think that we are, quite literally, made of stardust? Continuing with this theme of connectivity, consider how supernovae might impact life on Earth. While a supernova occurring nearby could be catastrophic, they also have the potential to influence our planet in more subtle ways. For instance, an increase in cosmic rays from a supernova can lead to changes in our atmosphere, potentially impacting weather patterns and climate. Did you know that supernovae are sometimes used to test the limits of our understanding of physics? The extreme conditions present during these explosions offer a natural laboratory for studying phenomena that can't be replicated on Earth. This includes investigating the behavior of particles at high densities and temperatures, providing insights into the laws of physics under such extraordinary circumstances. And here's a curious fact. Supernovae might have played a role in influencing biological evolution on Earth. Some researchers hypothesize that increases in cosmic radiation from nearby supernovae could have driven genetic mutations, potentially contributing to the diversity of life we see today. It's a humbling reminder of how deeply connected we are to the cosmos. Another aspect of supernovae that captures the imagination is their ability to create nebulae. The material ejected during a supernova forms expansive and colorful clouds of gas and dust, known as supernova remnants. These nebulae are not only visually stunning, but they also serve as important sites for studying the aftermath of stellar explosions and the complex interactions that occur in their wake. Let me share something intriguing about zombie stars. Occasionally, a star that has gone supernova might leave behind a remnant that contributes to a second explosion. This happens when a neutron star or black hole draws in material from a nearby companion star, igniting another series of explosive events. These so-called recurrent or repeated supernovae add yet another layer of complexity to our understanding of stellar life cycles. Finally, consider this astonishing fact. Scientists are exploring the idea that detecting supernovae in distant galaxies can help identify planets that might be capable of supporting life. The presence of certain elements and compounds created by supernovae could be indicative of conditions that favor the development of life, offering a cosmic clue in the search for extraterrestrial habitats. This possibility expands our understanding of how supernovae might influence the potential for life elsewhere in the universe. Each fact about supernovae unravels a little more of the universe's mysteries, inviting us to marvel at the dynamic and interconnected nature of cosmic phenomena. As we continue to gaze into the depths of space, these stellar explosions remind us of the ever-evolving story of the cosmos and our place within it. Let me share something truly mesmerizing. When a star goes supernova, it releases more energy in just a few seconds than our sun will emit over its entire lifetime. Imagine the sheer power of such an event, a cosmic fireworks display that outshines entire galaxies for a short period. This immense energy release is a spectacle that even the vastness of space cannot conceal. Speaking of brightness, did you know that supernovae can be so luminous that they are visible with the naked eye from Earth, even if they occur in distant galaxies? The famous supernova of 1680 in the constellation of Cassiopeia was one such event, shining brightly enough to be seen during the day. It's fascinating to think that these distant explosions can momentarily become part of our earthly sky. Here's a curious fact. Supernovae can actually affect the rotation speed of the core remnants left behind. The collapse of a massive star's core can cause it to spin at incredibly high speeds, sometimes up to several hundred times per second. This rapid rotation is due to the conservation of angular momentum, a principle that also explains why a figure skater spins faster when they pull their arms in. And did you ever ponder how supernovae contribute to the magnetic complexity of the universe? The remnants of these explosions can generate intense magnetic fields, much stronger than those found on Earth. These fields can influence the behavior of charged particles in space, creating phenomena like cosmic rays that travel across vast distances. Another fascinating aspect is the role supernovae play in seeding the universe with elements. Without these explosive events, the universe might lack many of the elements essential for life as we know it. From the calcium in our bones to the iron in our blood, these elements were forged in the heart of dying stars, scattered across the cosmos in their final, fiery breath. Consider the complexity of supernova remnants. They are not merely clouds of gas and dust. They are intricate structures shaped by the interplay of shock waves, magnetic fields, and interstellar material. These remnants can persist for thousands of years, offering astronomers a glimpse into the life cycle of stars and the evolution of galaxies. Here's something to pique your curiosity. Supernovae have been linked to the production of cosmic dust, which is crucial for the formation of new stars and planets. This dust, composed of silicates and carbon compounds, acts as the building blocks for future stellar systems. So, in a way, each supernova explosion contributes to the cosmic recycling process, perpetuating the cycle of creation and destruction. Imagine this: the shock waves from a supernova can travel at speeds exceeding 10,000 kilometers per second. At such velocities, these shock waves can traverse incredible distances, impacting surrounding clouds of gas and dust. This interaction is not just a physical spectacle, it's a transformative process that can trigger the birth of new stars, continuing the life cycle of the cosmos. Speaking of transformation, did you know that the energy from a supernova can heat the surrounding interstellar medium to temperatures of millions of degrees? This high-temperature environment can catalyze chemical reactions that might not occur otherwise, influencing the composition of the galaxy and adding to its chemical diversity. Here's something intriguing. Some supernovae are thought to be the source of short gamma-ray bursts, which are among the most energetic events in the universe. These bursts can release as much energy in a few seconds as the Sun will in its entire 10 billion year lifespan. The link between supernovae and gamma-ray bursts continues to be a rich area of study, offering insights into the most extreme conditions in the universe. Did you know that supernovae can leave behind pulsars, which are rapidly rotating neutron stars that emit beams of electromagnetic radiation? These cosmic lighthouses can be observed from Earth when their beams sweep past us, serving as precise cosmic timekeepers that help astronomers study the universe. And consider this: the gravitational waves generated by supernovae can ripple through space-time, offering a new way to observe these explosive events. As our detection capabilities improve, scientists hope to use gravitational waves to learn more about the inner workings of supernovae and the conditions inside collapsing stars. Another fascinating detail involves the role of supernovae in shaping galaxies. These explosions can inject energy and momentum into the interstellar medium, influencing the formation and evolution of galaxies. By driving gas outwards, supernovae can regulate star formation and contribute to the dynamic balance of galactic ecosystems. Lastly, ponder the idea that supernovae might have also played a role in the history of Earth. Some researchers propose that past supernovae could have triggered mass extinctions by altering our planet's climate or increasing cosmic radiation levels. While this remains a topic of scientific debate, it highlights the profound influence that cosmic events can have on life on Earth. As we delve into the mysteries of supernovae, each discovery deepens our appreciation for the intricate tapestry of the universe. These stellar explosions, in all their complexity and power, are reminders of the ever-changing nature of the cosmos and our intimate connection to the stars. Imagine this: the core collapse of a massive star in a supernova can create an incredibly dense object known as a neutron star, where a teaspoonful of its material would weigh about as much as a mountain on Earth. Isn't it astounding to think of such density? This extreme compression of matter is a testament to the powerful forces at work during a supernova. And did you know that neutron stars can sometimes be so dense that they bend light around them, creating a gravitational lens effect? This fascinating distortion of light offers a glimpse into the strange and wondrous phenomena predicted by Einstein's theory of general relativity. Here's another captivating insight. Not all supernovae result from the death of a single massive star. Some occur when a white dwarf star in a binary system accretes enough material from its companion to reach a critical mass, leading to a runaway nuclear fusion reaction. This type of explosion is known as a Type 1 supernova, and it serves as a crucial tool for astronomers measuring distances across the cosmos. These reliable cosmic yardsticks are instrumental in understanding the expansion of the universe and the mysterious force of dark energy. Speaking of cosmic measurements, supernovae have contributed significantly to our understanding of the universe's age. The discovery of certain supernovae in distant galaxies has helped scientists refine estimates of cosmic expansion, providing clues about the universe's beginnings. Isn't it fascinating that stellar explosions, so dramatic and fleeting, can offer insights into the profound questions about time and space? Consider the visual spectacle of a supernova remnant interacting with nearby cosmic objects. These interactions can create beautiful light shows, such as the Veil Nebula, which is a remnant of a supernova explosion that occurred thousands of years ago. As the shockwave from the explosion travels through space, it illuminates and excites the gas and dust in its path, resulting in a luminous tapestry that dazzles the eyes. It's a reminder of the artistic beauty that emerges from cosmic chaos. Let's turn our attention to the impact of supernovae on chemical enrichment. These explosions are responsible for creating heavy elements like gold and platinum, which are not formed in the regular fusion processes of stars. The violent conditions during a supernova provide the extreme environments needed for these elements to form, meaning that every piece of gold jewelry you own owes its existence to the death throes of ancient stars. Isn't it remarkable to think that these precious metals are truly cosmic heirlooms? And here's an intriguing thought. The light from a supernova can take thousands or even millions of years to reach us. So when we observe these explosions, we are looking back in time. This time travel effect allows astronomers to witness events that occurred long before humanity existed, offering a glimpse into the early history of the universe. It's like peering through a cosmic time machine, with each flicker of light telling a story from eons past. Did you ever wonder about the variety of life in the universe being influenced by supernovae? Some researchers speculate that the radiation from nearby supernovae might spark mutations in biological organisms, potentially accelerating evolutionary processes. While this idea is still hypothetical, it highlights the interconnectedness of cosmic events and life. Even distant explosions can have ripple effects that reach across the cosmos, touching the very fabric of life. Here's a surprising fact. The study of supernovae has also led to the discovery of new celestial phenomena, such as kilonovae. These events occur when two neutron stars merge, releasing enormous amounts of energy and creating heavier elements. Kilonovae are thought to be responsible for producing elements like gold and platinum on a grand scale. These discoveries continue to expand our understanding of the complex interactions that shape the universe. Speaking of discoveries, did you know that supernovae have been used to study the properties of neutrinos, elusive subatomic particles that are incredibly difficult to detect? When a supernova occurs, it releases a flood of neutrinos that can be picked up by sensitive detectors on Earth. These ghostly particles provide valuable insights into the processes occurring deep within the exploding star, offering clues about the physics of the universe at its most extreme. Finally, let's explore the cosmic ballet of star formation triggered by supernovae. The shock waves from these explosions can compress nearby clouds of gas, kick-starting the process of star birth. This cyclical pattern of destruction and creation is essential for the continuous renewal of the universe. Each new generation of stars carries with it the legacy of the supernovae that came before, a testament to the perpetual dance of energy and matter. As we continue to unravel the mysteries of supernovae, each discovery enriches our understanding of the universe's complexity and our place within it. These celestial phenomena, with their explosive power and intricate beauty, remind us of the delicate balance that governs the cosmos. In contemplating the life cycle of stars and the explosive ends they sometimes meet, we find ourselves ever more connected to the stars, both in the vastness of space and the depths of our own existence. Let me share something intriguing with you. Supernovae are not just cataclysmic events, but also light beacons that can outshine entire galaxies for a brief time. Imagine a single stellar explosion temporarily exceeding the brightness of billions of stars combined. This immense luminosity allows astronomers to study supernovae even in distant galaxies, making them invaluable tools for exploring the universe. Now, consider the idea of a supernova as a cosmic forge. Did you know that without supernovae, the universe would lack many of the elements necessary for life? The intense energy of a supernova is crucial for the synthesis of elements heavier than iron. This stellar alchemy disperses newly formed elements into space, seeding future generations of stars and planets with the building blocks for life as we know it. Here's a fascinating thought. While we often associate supernovae with destruction, they can also reveal long-hidden secrets about their host galaxies. These explosive events can strip away obscuring dust clouds, uncovering previously hidden structures and allowing astronomers to peer into the heart of galaxies. In this way, supernovae act as cosmic archaeologists, shedding light on the universe's hidden corners. And here's something rather unexpected. The shock waves from supernovae are not just randomly spreading energy, but are meticulously sculpting the interstellar medium. These shock waves can trigger the formation of intricate filamentary structures in the gas and dust of the galaxy. It's as if each supernova is painting a new masterpiece across the cosmic canvas, adding layers of complexity to the universe's visual tapestry. Speaking of remarkable structures, did you know that certain supernovae can leave behind a spinning remnant known as a pulsar? These rapidly rotating neutron stars emit beams of radiation from their magnetic poles. As they spin, they create a lighthouse effect, with their beams sweeping across the sky. Pulsars serve as incredibly precise cosmic clocks, helping scientists test the laws of physics under extreme conditions. Another surprising fact is that supernovae can influence galactic weather. The energy released during a supernova explosion can drive powerful winds that blow gas out of the galaxy. This process, known as galactic feedback, regulates star formation by preventing excessive accumulation of gas, maintaining a delicate balance that influences the overall evolution of galaxies. Here's an interesting twist. Some supernovae are not as explosive as you might think. There's a type known as a failed supernova, where a massive star collapses directly into a black hole without a significant explosion. These stealthy events are challenging to detect, but their existence suggests that the fate of massive stars can be more diverse than previously believed. Imagine this. Certain supernovae have been linked to gamma-ray bursts, the most energetic and luminous electromagnetic events in the universe. These bursts occur when a supernova's core collapses and forms a black hole, releasing intense gamma-ray jets. It's a reminder of the mind-boggling energies at play during these cosmic cataclysms. Did you ever wonder if supernovae could be responsible for cosmic rays? Indeed, these high-energy particles streaming through space are believed to be accelerated by the shock waves of supernovae. They provide a unique opportunity to study the interactions between cosmic rays and the interstellar medium, offering clues about the universe's high-energy processes. Here's a curious phenomenon. Supernovae have been observed to occur in certain galaxies more frequently than others. This clustering of stellar explosions might be influenced by the galaxy's environment, composition, and history, providing insights into the life cycles of stars across different cosmic neighborhoods. Have you ever heard of supernova imposters? These are stellar explosions that mimic the appearance of a supernova but fall short of the full explosive potential. Often associated with massive stars ejecting large amounts of material, these events challenge astronomers to distinguish between genuine supernovae and their imposters, revealing the diverse outcomes of stellar evolution. And speaking of variety, there's the peculiar case of pair instability supernovae. Unlike typical supernovae, these explosions occur when extremely massive stars become unstable due to the production of electron-positron pairs in their cores. The resulting explosion is so powerful that it can completely disrupt the star, leaving no remnant behind. These rare events push the boundaries of our understanding of stellar physics. Here's a thought to ponder. Supernovae might have played a role in the extinction events on Earth. The radiation and cosmic rays from a nearby supernova could potentially alter Earth's climate or atmosphere, influencing the course of life. While this is still a topic of research, it highlights the far-reaching consequences of these distant explosions. Lastly, consider the role of supernovae in galactic recycling. When a star explodes, it enriches the surrounding space with elements which can later become part of new stars and planets. This cyclical process of destruction and creation ensures the continual renewal of the cosmos, with each supernova contributing to the complex web of cosmic evolution. As we drift deeper into the mysteries of the cosmos, the study of supernovae continues to illuminate the universe's intricate dance. Each explosive revelation brings us closer to understanding the delicate interplay of forces that shape our celestial home. And in this dance, we find not only the story of stars, but also the story of ourselves, written in the stardust that composes our very being. As we continue to explore the mesmerizing phenomena of supernovae and stellar explosions, let me share a rather intriguing insight. These cosmic spectacles are not just chaos unleashed, but are in fact one of the universe's most efficient ways to recycle matter. When a supernova occurs, the outer layers of the exploding star are hurled into space, dispersing elements like carbon, oxygen, and nitrogen. Imagine, every breath you take contains atoms that were once part of a star. This recycling of star material is fundamental to the ongoing evolution of galaxies, ensuring that the materials necessary for life continue to circulate across cosmic time. Speaking of life, consider this. Some scientists hypothesize that supernovae might play a role in kickstarting the formation of solar systems. The shock waves from a nearby supernova can compress gas and dust in a molecular cloud, triggering the collapse of regions that eventually coalesce into new stars and planets. It's fascinating to think that the violent end of one star could be the gentle beginning of a planetary system similar to our own. Here's a particularly surprising fact. Supernovae can actually be used to measure vast distances across the universe. Certain types of supernovae, known as type O supernovae, have a consistent intrinsic brightness. By comparing their known brightness to how dim they appear from Earth, astronomers can determine their distance. This has made type E supernovae invaluable standard candles for mapping the expansion of the universe, providing key evidence for the existence of dark energy. In another unexpected twist, supernovae might also be responsible for the occasional mass extinctions here on Earth. The idea is that a supernova occurring within a few dozen light-years could send a shower of high-energy particles and radiation towards our planet. This cosmic bombardment could deplete the ozone layer, altering the climate and ultimately affecting life on Earth. While this is still theoretical, it underscores the profound influence these distant explosions could have on our planet. On a smaller scale, did you know that supernovae can also create rare and valuable isotopes? One such example is aluminum-26, a radioactive isotope whose presence in meteorites suggests that a nearby supernova exploded shortly before the formation of our solar system. This hints at the possibility that the very birth of our planetary neighborhood was influenced by the death throes of a massive star. Another captivating aspect of supernovae is their connection to cosmic rays. These high-energy particles originate outside our solar system and are thought to be accelerated by the shock waves of supernovae. Cosmic rays constantly bombard the Earth, and while they pose no significant threat, they do offer scientists a unique tool for studying the universe's high-energy processes. It's amazing to think that particles originating from a distant supernova might be passing through your body right now. Let me tell you about an intriguing cosmic dance. Some supernovae occur in binary star systems, where two stars orbit each other. In these systems, matter can be transferred from one star to another, eventually leading to conditions ripe for a supernova. This interaction not only offers a unique setting for a stellar explosion, but also enriches our understanding of how stars evolve in pairs, leading to a variety of explosive outcomes. You might be curious about how supernovae leave their imprint on the cosmos. One such remnant is the Crab Nebula, a famous example of a supernova remnant visible to the naked eye under dark skies. Located in the constellation Taurus, the Crab Nebula is the remnant of a supernova observed by Chinese astronomers in the year 1050-4. The nebula continues to expand at an astonishing rate, offering a lasting testament to the power of stellar explosions. Here's something rather poetic. The light from a distant supernova can take millions of years to reach Earth, meaning we are witnessing events that occurred in the distant past. This time-traveling light allows us to peer into the history of the universe, capturing moments that have long since passed. It's as if we're reading a cosmic diary, filled with tales of creation and destruction written in the light of long-gone stars. And did you know that supernovae have been inspiring human imagination for centuries? Historical records from diverse cultures across the globe describe bright new stars appearing in the sky, leaving an indelible mark on the observers of the time. These celestial events were often seen as omens or divine messages, underscoring the deep and lasting impact that supernovae have had on human culture. As we wrap up this starlit journey through the realm of supernovae, remember that these celestial explosions are not merely points of light in the sky. They are profound events that shape the very fabric of the universe and offer glimpses into the cosmic processes that govern life, death, and rebirth on an unimaginable scale. Whether through the creation of elements, the formation of planets, or the expansion of galaxies, supernovae continue to be the universe's tellers of tales, each explosion a chapter in the grand story of the cosmos. Did you know that the brightness of a supernova can actually outshine an entire galaxy for a brief period? This astonishing luminescence is the result of the immense energy released in the explosion, which can equal the energy output of billions of suns. Imagine looking up at the night sky and seeing a single point of light as bright as all the stars in a galaxy combined. It's a reminder of the incredible power contained within these stellar phenomena. Speaking of brightness, there's a fascinating aspect to how supernovae illuminate the universe. When a supernova occurs, it not only brightens up the night sky, but also lights up nearby clouds of gas and dust. This can lead to the formation of what's known as a reflection nebula, where the light from the supernova is scattered by surrounding materials, creating a spectacular cosmic display that can last for thousands of years. One intriguing consequence of supernova explosions is their potential to create new star systems. The shock waves generated by these explosions can travel through interstellar space, compressing clouds of gas and dust and triggering the birth of new stars. It's a cosmic cycle of death and rebirth, where the end of one star can lead to the genesis of many more. Here's a surprising twist. Not all supernovae are created equal. Some, known as core collapse supernovae, occur when massive stars exhaust their nuclear fuel and their cores collapse under the force of gravity. Others, like the Type 10 supernovae we mentioned earlier, result from the explosion of white dwarfs in binary systems. These different types of supernovae offer a rich variety of insights into the life cycles of stars and the complexities of stellar evolution. And here's something truly mind-bending. Supernovae can create gravitational waves. When massive stars collapse or when two neutron stars merge, the resulting supernova can send ripples through the fabric of space-time. These gravitational waves travel across the cosmos, offering a new way for scientists to observe and understand the universe. It's like listening to the universe's heartbeat, one that's been beating for billions of years. Have you ever wondered about the role of supernovae in the creation of black holes? When particularly massive stars explode, their remnants can collapse into black holes, regions of space where gravity is so strong that even light cannot escape. These enigmatic objects are among the most mysterious in the universe, and supernovae provide a pathway for their formation, linking the life cycles of stars to the most extreme environments known to science. Speaking of extremes, consider this. The temperatures at the heart of a supernova explosion can reach billions of degrees. This intense heat facilitates nuclear reactions that produce heavy elements like gold and uranium, elements that eventually find their way into planets, including our own. The very gold you might wear as jewelry today was forged in the heart of a supernova, connecting us to these cosmic cataclysms in a personal way. Another captivating fact is the role of supernovae in sculpting the interstellar medium. The shock waves from these explosions can sweep through space, clearing out regions of gas and dust and shaping the structure of galaxies. This dynamic process contributes to the formation of new stars and planets, demonstrating how supernovae are both destructive and creative forces in the universe. Interestingly, supernovae have a link to cosmic timekeeping. By studying the light curves of supernovae, astronomers can determine the amount of time it takes for them to reach peak brightness and fade away. This timing can help calibrate the cosmic distance ladder, a method used to measure distances to far-off galaxies. In this way, supernovae help us map the vastness of the universe, offering a celestial clock that ticks on an astronomical scale. Have you considered the idea that supernovae might influence the habitability of planets? The radiation and particles from a nearby supernova could alter the chemistry of a planet's atmosphere, potentially affecting its climate and the conditions for life. While this remains a topic of ongoing research, it highlights the interconnectedness of cosmic events and the potential impact on planetary environments. Can you imagine the sound of a supernova? While sound doesn't travel through the vacuum of space, if you could somehow hear these explosions, they would be unimaginably loud. The energy released would dwarf any sound produced on Earth, a testament to the sheer scale of these cosmic events. Here's a thought-provoking concept. Supernovae are essential for the cosmic balance. By returning enriched material to the interstellar medium, they ensure that galaxies remain active and vibrant over billions of years. The elements produced in supernovae are necessary for the formation of new stars, planets, and even life, maintaining the continuous cycle of matter in the universe. Finally, remember that supernovae can be seen as both an end and a beginning. They mark the end of a star's life, but also herald new opportunities for cosmic creation. Each explosion is a reminder of the transient nature of the cosmos, where change is the only constant, and every ending is the precursor to a new beginning. As you drift off to sleep, think of the universe's grand tapestry woven with the threads of supernovae, each one a brilliant burst of light and energy echoing across the cosmos.